Hello everyone, today class number 22 for electrical machine 2. Class number 22 for electrical machine 2. Okay. So let's start. The today's topic is the construction of single phase induction motor. Construction of single phase induction motor. Okay, so let's write single phase induction motor is very simple and robust in construction. Single phase induction motor is very simple and robust in construction. Okay, first point. Next, right. The stator carries a distributed winding in the slots cut around the inner periphery. The stator carries a distributed winding in the slots cut in the inner periphery. In the inner periphery. Okay, so third point. The stator conductors have low resistance and they are low resistance, and it has another additional conductors mounted over the stator called auxiliary winding used for the generation of starting torque. Okay, so fourth point, right. The rotor is, this is 3 points for stator part, and now I will move into the rotor. The rotor is invariably of the squirrel cage type. Okay. The main stator and auxiliary windings are joined together in parallel combination. at the time of starting they are connected in parallel, and after achieving the 75% of rated speed, the auxiliary windings may gets cut off. Okay, so this is all about the construction part of three-phase single-phase induction motor. So now you have to draw a figure for three-phase induction motor. Suppose we are taking a cross section. We are taking a cross section of it. Okay, so so let us first draw it, then discuss. Okay, let us first draw it. So make a bigger figure. Make a bigger figure. Okay. Okay, so this type of constructions is available for single phase induction motor. So now this is the first one is stator slot. This is stator slot over which the stator conductors are installed. Stator conductors are installed, and then this is stator laminated core. Okay, that is stator core with lamination, and this one is shaft. Okay, and this is the air gap. This small section, this is the main, this is the rotor, this is the stator. Okay, so this small portion gap is called air gap. Okay, and this is rotor slot. Actually there is no connection. Okay, so remove the connection first. There is no connection of it. Okay, so just remove it. Okay, and this is the rotor slot over which the rotor conductors are installed. Okay, what is the rotor conductors are installed, and this is the rotor house. Okay, so this is the construction part of a single phase induction motor. So after that I will move into the next topic, that is the operating principle of single phase induction motor. The operating principle of single phase induction motor. Operating principle of single phase induction motor. Okay, right. A single phase induction motor consists of, right, a single phase induction motor consists of distributed stator winding and an additional winding for starting purpose in stator. Okay, so first point, write this sentence. Second point, write and single phase input is given to a single phase AC supply is given to the stator coil. So this is stator coil, and this is auxiliary AW, that is auxiliary winding. Okay, so single phase AC supply is given to the stator coil. Next line, a current will flow through the stator coil. That will produce a stator coil flux B1 or stator coil flux phi 1. That will produce the stator coil flux phi 1 in the air gap, and this production of flux, next point, the generation of or the generated flux by stator coil only, is pulsating in nature, that produces a pulsating torque to the rotor, that produces a pulsating torque to the rotor. Next point, thus stator coil alone could not start the motor. So basically an additional winding called auxiliary winding. Next point. So basically an additional winding called auxiliary winding is connected. So basically an additional coil called auxiliary winding is connected in parallel to the stator main coil. Is parallel to the stator main coil through some centrifugal switch, through some CS, that is centrifugal switch, through some centrifugal switch. That is in point next line. That is at starting moment. That is at starting moment. This CS centrifugal switch remains closed. Centrifugal switch remains closed. Thus, the stator field becomes two-phase fields, respectively phi 1 and phi 2 are produced to the air gap simultaneously. Air gap simultaneously. The interaction between phi 1 and phi 2 will produce and rotating magnetic field inside the air gap. Produce and rotating magnetic field inside the air gap. So the production of the rotating magnetic field performs and resultant torque generation inside the rotor. Performs the resultant torque generation inside the rotor, which can rotate the rotor in a particular direction. Next point. Gradually the rotor increases its speed. And at 75% of the rated speed, the centrifugal switch is automatically cut out. This centrifugal switch is automatically turned off, and the auxiliary winding is cut out from the stator field. That is the stator windings. So auxiliary winding is cut out from the stator windings. So next point. So with only the main stator coil, the rotor will continue to run. Until or unless single phase supply is given to the stator part. Until or unless single phase stator coil, single phase AC supply is given to the stator coil. Okay. So next write para change using the para, then write the analysis of the single phase motor. The analysis of the single phase motor can be made on the basis of two theories. First one, write double revolving field theory and cross field theory. Okay, these two theory on the basis of these two theory, the single phase induction motor actually runs. Okay, so in next class I will discuss the double revolving field theory and the cross field theory. Okay, so wait for the next day. So today's class up to this much, and thank you.